Hi, everybody. This is a narration of the first week of distance learning, polynomial operations review. Learning target for today, I will review polynomial operations so that I can successfully simplify algebraic expressions. Now, we did this before, but we're going to review it one more time. We're going to review how to classify a polynomial by the number of terms. So remember, we can name expressions by the number of terms. Terms are separated by positive and negative signs. And that is key. That will be key, especially for the next couple of problems. So yeah, this is plus and minus signs. All right. An algebraic expression is a polynomial with many terms. Polynomial means many terms. Now for the first example, negative 3x squared over 4, that's a monomial, or one term. The second expression, x to the third power minus 4x, that's a binomial. Binomial, two terms. Then the last example, 5x squared minus 4x minus 1, that's a trinomial, three terms. Again, monomial, one term. You could have a plus or minus sign, or it could just be a plain term, no sign, then it's positive. Here, you have a positive x to the third. You don't see a sign, assume it's positive. Minus 4x. Here, these two terms are separated by a minus sign. For the last one, 5x squared minus 4x minus 1. 5x squared and 4x are separated by a minus sign. Then the 4x is separated with the 1 also by a minus sign. Now, adding polynomials. You combine like terms. When you combine like terms, you add coefficients. Your coefficient, do not forget, is the number that is to the left of your variable. So in this case, you have the 4a to the fourth, 8a to the fourth. And again, this is your coefficient of 4a. Oh, I'm going to redo it a different way. Hold on a second. So, oops, a little bit too far. So now what's going to happen? We are going to highlight the coefficients. So 4 and 8. So here we add 4a to the fourth plus 8a, that is also to the fourth. And then our next step is, oops, let me make that a little smaller so we can see that a little better. Okay. Now, oops, too small, too small. Make that a little bigger. Perfect. All right. That's not what we wanted. We did not want it to disappear. There we go. Better. Sorry for my technical difficulties here, ladies and gentlemen. Okay. Now, negative 3a squared. We're just going to type it as negative 3a squared. Then we have plus 5a minus 7a. Now, the key for this whole problem, some of us were not sure whether we were adding or multiplying, especially for anybody who thought this was a multiplication problem. What we need to do is you need to look that this plus sign between the two sets of parentheses, that tells us we are adding polynomials. Again, I cannot stress enough, when you see this plus sign, you add your polynomials. I cannot add polynomials. Too many, quite a few of us, before we left school, we thought, oh, we had to multiply. No, that plus symbol between your two sets of parentheses tells us to add your polynomials, which means just combine your like terms. And then once you combine your like terms, just add your coefficients. 4 plus 8 is 12. 8 to the fourth does not change. Negative 3a squared, that's going to stay negative 3a squared because that's the only a squared term out of all the terms we see here. And then positive 5a minus 7a becomes negative 2a. Then you could do it vertically as well, where you take your first polynomial and then you write the second polynomial directly underneath. Again, look at your like terms. Like terms, same variables, same exponents. And even here, 5a, 7a. You don't see an exponent, but in both cases, the exponent is 1. Now, subtracting polynomials. Similar to adding polynomials. Again, see this sign right here? That's the most important sign. Again, too many of us thought this meant you multiply by negative 2b to the third, negative 5. This just means subtract your polynomials. That's all. Subtract polynomials. That is the key. Again, I cannot stress enough. I mean, some of you thought you were okay to multiply your terms. Not here. Again, minus sign between the two sets of parentheses. That means you're subtracting. And in this case, do not forget, this is a negative 1. So you need to distribute this negative 1 to both 2b to the third and the positive 5. That's why we wind up with a negative 2b to the third and a negative 5. And then, of course, after you do your distribution, of your minus sign to each term within the second set of parentheses, then we do need to write our polynomial. We need to combine our like terms. So here, this would be a negative 5b to the third power. And it's minus, sorry about that, minus 2b to the third. Okay, I apologize, we've got a delay here. There we go. Minus 2b to the third. And then it is plus 3b squared minus 2b, oops, I'm sorry, minus 4, just a single minus 4, minus 5. So we have, so negative 5b to the third minus 2b to the third. That's how we have our negative 7b to the third. And then positive 3b squared just stays. That's the only b squared term throughout this whole polynomial. And then you have negative 4 minus negative 5. That gives us negative 9. So this should be familiar. This should be material we've went over in the past. We will just go over it one more time as a review. Now the next step, distributing a monomial. Here, you multiply coefficients, you add your exponents. So similar to before, whenever you see a term outside the parentheses, you must multiply, i.e. distribute to each and every term within the set of parentheses. So now what we do is we're going to multiply. So the step here is 3x times x squared minus 3x times 5x, and then plus 3x times 9. And then after that, remember, x times x squared, that's how we get x cubed. 1 plus 2 was 3. Here, for the middle, 3x times 5x, 15x squared. Again, remember, you don't see it, but that's a 1. 1 plus, there's a 1. There's a 1. And then, last but not least, 3x times 9, 27x. This is a 1, but that's just a plain old 9, so you're just going to multiply the whole numbers, bring down your x. Then there's also the boxing method. Think about this as a multiplication table. Same thing, 3x times x squared, 3x to the third, 3x times negative 5x, negative 15x squared, 3x times positive 9. We don't see it. You can say plus 9, and then we have plus 27x. So in the end, oops, there we go. Just bring down your terms. with the appropriate signs, and you're done. Now, for the next part of this activity, dividing a monomial. Dividing coefficients. So when you divide a polynomial by a monomial, you're first going to give this denominator, or you're going to break up your numerator into small, just single monomials, but keep your signs. So this minus sign just comes on down for the ride. This plus sign just comes on down for the ride, but we still need those to separate our terms. And then from here, you see that 16x to the fourth divided by 4x squared. So remember, 16 divided by 4 is 4. And then x to the fourth divided by x squared. Remember, you subtract x to the 4 minus 2. That's how we get 4x squared. Because 16 divided by 4, 16 goes into 4 times. And then 4 goes into itself once. Similarly here, minus sign just keeps coming down. 24 divided by 4, 24 goes into 4 6 times. And then 4 goes into itself once. And again, do we need the 1 in the denominator? No. And then, of course, you have 6x to the 3 minus 2, which becomes 6x to the first, or in this case, since we know if the exponent is 1, we just leave it as 6x. Now the last part, again, is key. Remember, this plus sign comes on down for the ride. Now 20 divided by 4 is 5 with a 1. Now here, so we get the 5, but now this part right here. X to the 2 minus 2. Ladies and gentlemen, 2 minus 2 is 0. So it would be 5x to the 0. But x to the 0, in the end, is 1. Well, x to the 0 part. So that means, when all is said and done, the x to the 0 just disappears. But you have to keep your coefficient, which is the 5. Well, in this case, the coefficient just becomes a constant. Similarly, you could do reverse box method. The goal is, once you do your multiplication, 4x squared times 4x squared, you get 16x to the fourth. 4x squared times negative 6x, negative 24x to the third. 4x squared plus 5, positive 20x squared. And what we will be doing soon is actually doing the reverse. We're actually going to get a polynomial, and then we need to figure out what the greatest common factor is of your coefficients, and we will look at your variable portion of your term. Now, multiplying binomials. X minus 6 times 2x plus 3. One way to do it is you can distribute the first term to each term within the second set of parentheses. So we have x times 2x, and then x times positive 3. Similarly for the second term, you give the negative 6. So you do have to include that negative with the 6. That's why I'm underlining it here. So we see that it's negative 6, not 6, but negative 6 times 2x is negative 6 times positive 3. So again, negative 6 times 3. And then as a result, we do our multiplication. Again here, exponent of 1. So keep your coefficient, add your exponents. 2 times x times another x is 2x squared. And you have x times 3, positive 3x. Negative 6 times 2x, negative 12x. Negative 6 times 3, negative 18. And then you may need to combine your like terms. In this case, positive 3, negative 12x. Oh, I'm at positive 3x and negative 12x. We can combine those two terms. Basically, you are subtracting 3 minus 12, or positive 3 minus 12 is a positive 9. So in the end, 3x minus 12x gives us negative 9x. That's our middle term. And then this first term, the 2x squared, comes on down for the ride. Negative 18 also comes on down for the ride. Now remember, we have to include these terms. And we want to try to keep the terms such that in order where highest exponent on the left, lowest exponent on the right. That's rule of thumb. Now there's also the box method. So what happens? Set up your 2x2 grid. You can take your first set of terms, in the first set of parentheses, take your first set of terms. You can put them here. You could have also put them here, 3a, negative 1. You don't have to. And then you have a and negative 5. Again, highlight, we cannot forget our signs. And again, this we have seen before, so I'm not going to go too much into detail. We've done this before, and you guys did a really good job. So now, like before, this acts like a multiplication table. But here's where some of us made mistakes, especially for getting exponents. 3a times a, 3a squared. Again, some of us just did not include that a. I mean, to the second power. You guys just said 3a. And that turned out to be a mistake down the road because then we combined a bunch of terms that we weren't supposed to combine. Negative a times negative 1. It's negative a, even though you don't see it. You'd say negative 1a. Negative 5 times positive 3a, negative 15a. Negative 5 times negative 1 is positive 5. So what you would do, you could line up your terms. 3a squared minus 1a minus 15a plus 5. Now again, you don't see a sign, assume that it's positive, because we do need to separate signs with terms with plus and minus signs. And then we see that negative 1a minus another 15a. Since they're all negatives, keep the negative sign, but you add your two numbers. 1 plus 15 is 16. And then the a we keep. And then the other two terms on your ends, the 3a squared comes on down for the ride. So does the positive 5. That too comes on down for the ride. Now, multiply binomials using the area model. Now this one we haven't really used too much, but it's sort of similar to the box method, where what you do, these rectangles, the small rectangles are your x's, and then these little squares are positives, in this case positive ones, and then again, you have another positive rectangle, and then you have negative ones. And then similar to before, multiply. So x times x, there's x squared. X times 1, x. X times another one, another x. X times one, another one, another x. Now here, x times negative 1, negative x. X times another negative 1, another negative x. You have 2 negative x's. And so then last but not least, you have all these little boxes are negative 1s. So now, you have x squared. There's no other x squared, so that's the only one that's going to be an x squared term. So that's where this x squared comes from. Comes from this guy here. Now we see that we have 3 positive x's and 2 negative x's. So these 2 negative x's are going to cancel out with these 2 positive x's. So we're left with 1 more x. So this positive x, that's where we get this term here. And then last but not least, the 6 little negatives that are here. That's how we get our negative 6 down here. And that's how we have this final result of x squared plus x minus 6. Now, there are going to be videos available to you. These videos will actually be featured on Google Classroom. I will post up the actual Google Slide document that portrays this video. And then you will have 2 assignments, a math space and an e-cart that will be posted on Friday, April 17th. So please check both math space and e-cart and Google Classroom as well. Now, these independent practice problems, now these have been posted before. You guys may have seen these before on these 3 slides. Now, what I'm going to do on the worksheet, I have given you hints on how to do some of these problems. Now, some of these problems, actually quite a few of them, look familiar because that was part of a homework assignment that I had requested to collect before the break. And it was mainly paid the last 2 sets of problems. Problems 6 through 15 were part of a homework assignment. There was also another homework assignment that was given to you. Well, there was another page that had addition problems. Now, those 3 slides are very similar to a homework assignment I gave you guys before school closed. So please check your assignments. You may have done some of these already. Now, on the document that will be posted with this video and the Google Slides also gives you hints on how to complete these problems. As always, feel free to contact me if you have any questions. Thank you so much. Take care.